Hi everyone, in this video lesson you're going to learn how to solve systems of equations by elimination, and notice we're going to have three variables in these examples for this lesson. Okay, so there's x, y, and z. So step number one, you're going to separate equations into two pairs and eliminate the same variable. So I've taken the first equation and the second equation. So what I am going to do is I'm going to notice that this is positive z and this is negative z. So then I can see right away that the z's are going to eliminate, right? So then I'm going to add 2x and 1x. That combines to 3x, negative y plus 3y, that's positive 2y. And that equals 4 plus 11, which is 15. Then I'm going to take the first equation, okay, so which is 2x minus y plus z, and combine that with the third equation. So 4x plus y minus z, and this is equal to 4, and this one is equal to 14. Then I'm going to add. So notice in this case we have the z's cancel, and we also have 0y, right? Because negative y plus y is 0y, so we have 0y, and then 2x plus 4x, that's 6x, and 4 plus 14, that's equal to 18. Okay, so then I'm going to take this equation and this equation on step number 2. So use the two new equations and solve like you had before. So copy 3x plus 2y equals 15, and then 6x plus 0y equals 18. Okay, so from here I'm going to eliminate the x's. So I'm going to open parentheses here, and notice that I have 3 x's here and I have 6 x's, so I need to make this 3 become a 6 if I want to eliminate the x's. So I'm going to multiply by negative 2. So once I do that, then I have negative 2 times x. I'm distributing, that's negative 6x. Negative 2 times 2y, that's negative 4y, equals negative 2 times 15, that's negative 30. And this equation, I am not going to do anything to it because I don't need to. I'm just going to copy 6x plus 0y. Notice I'm just writing 0y as a placeholder, okay, so I don't get confused. So then when I add the two equations, the x's cancel, so now we have negative 4y plus 0y. That gives us negative 4y, and that equals negative 30 plus 18, that's negative 12. Then let's divide by negative 4 on each one of the equations, each one of the sides. So then y is equal to positive 3. So we have the y coordinate at this point. Then I'm going to plug my answer, okay, or my two answers. Well, in this case so far, well, we just found y is equal to 3. So what I'm going to do next is I'm going to go to the first equation, or I can go to this one, either one of them, okay. So I'm going to go to the first equation and write down, we have, so this one here, 3x plus, we already know y is equal to 3, so plus 2 times 3 is equal to 15. Then solve. So 3x plus 2 times 3 is 6 equals 15. Then subtract 6 from both sides of the equation, so we have 3x equals 15 minus 6, that's 9. Then let's divide by 3. So then we find that x is equal to 3. So notice we have the x and the y coordinates. So what we need to find x is the z coordinate. So I'm going to plug in or substitute my two values for x and y into one of the original equations to get the third variable, which will be the z coordinate. Okay, so I am going to choose the first equation, which is this one here. So I'm going to write down 2x minus y plus z equals 4. But then 2x, we know x is 3, so that means 2 times 3 minus y is 3. Okay, so 3 instead of y plus z equals 4. 2 times 3 is 6 minus 3 plus z equals 4. 6 minus 3 is 3, so we have 3 plus z equals 4. Then when you solve for z, you just subtract the 3 from both sides of the equation. So then we find that z is equal to positive 1. So this is your introduction on solving systems of equations with three variables. Okay, so then the x-coordinate is 3. The y-coordinate is also 3. And the z-coordinate is 1. So these three lines will intersect where x is 3, y is 3, and z is 1. So that's a solution to this equation.